we go. Let's take a look at Chapter 9. Chapter 9 is a great one. It is Area. And when I think Area, I think of the classic video game Area 51. Such a great game. Love it. So let's take a look at Area. Whole chapter is about finding area of two-dimensional shapes. So let's make sure we're cool on that. Excuse me. Let's start off with parallelograms here. And let's just draw one in here. So parallelogram, I think the easiest one to see area would be something like this. Maybe go 1, 2, 3, 4. And maybe I'll go 1, 2, 3, 4, 5. Let's go 6. So if you check this out, so I'm just drawing a rectangle in here. And the reason I'm doing it is because what is this? This is 4 units this way. And this is a 4 by 6 rectangle. And let's pretend that these were centimeters. Each one of these boxes were centimeters. So this would be 6 centimeters wide. This would be 4 centimeters wide. So what can you do? I want to know the area. I want to know what is the area of this. Well, what does that mean? You have to count up all these boxes. Well, how many do you got? You've got 6 rows of 4. So if you count them all up, what do you got? You got 24. So why do I have 24? I have 24, and these are centimeter what? Well, look at this. What is this? This is now a squared centimeter. So this is centimeter squared because it's 1 centimeter by 1 centimeter. So the area of this is 1 centimeter squared. So I actually have 24 centimeters squared. So that's what area is. That's why it's squared. We're talking about these square little blocks inside of there. So what's the formula for a parallelogram? A lot of times you may think, yeah, it's length times width is the classic rectangle. We're going to refer to it from here on out as base times height. So what was the base of this? The base was 6. The height was 4. It was 6 times 4. So that's great for a rectangle parallelogram. That's a parallelogram. Opposite sides are parallel. But what about when I slant it up like this in a parallelogram? Does it still work? Yes, it still works. Just be careful. Where's your height? Your height is, you can think of it a couple of different ways. You can think of this as your height out here. And then this is your base over here. Or a lot of times we like to draw the height actually on the inside. So there's the height and the base. So this works for parallelograms, and a rectangle is a special case of a parallelogram. Excellent. So that's half of it, half the section right there. Let's try some. Make sure we're good with this. So I am doing base times height, and this is a rectangle, so this is going to be 3 times 6. Just make sure you label everything. So this is what? This is 18 meters squared. So we got to put that label in there, especially on match checks and whatnot, or else we're not going to count it. Make sure you have it in there. Does this freak you out? So now I've really got a parallelogram in here. So I can tell the base just happens to be on the side. The height is this dotted line through the middle with a right angle on it. So not a problem. This is going to be what? It's going to be base is 11. The height is 7.9. Bust out your calculator here real quick. Let's clear that out. We've got 11 times 7.9. So we're going to have some nice decimals in this one. We got 86.9. And again, what was our units? We're talking about yards squared. Fantastic. So we're just cruising. Let's do one more of these, make sure we're good to go. Does it freak you out when the height's on the outside out here? This is the height of the parallelogram. Oh, and this is a little bit different. I don't know the base. So now, if I have area equals base times height, the area is actually 12. I don't know the base. I'm going to call it x. And the height is 2. So can you solve this? And maybe you like to look at it like this. X times 2 is the same thing as 2x. And can I solve this? Sure. Just divide both sides by 2. What am I looking at here? 6. And what is this? This is actually 6 meters. So it's not square because I'm talking about this distance here, 6 meters. So maybe I'll give you the area. You got to find the missing side, or maybe I'll ask you to find the area. Fantastic. Moving on. What about triangles then? So triangles are really, the formula comes straight from a rectangle. Remember this was base times height is the area of this. Well, check this out. If I draw this across here, what do I have? I have two triangles, don't I? Here is a triangle here. So what is the area of this triangle? Well, the area is base times height. But what happens? I only want half of it. There are 2 triangles here, 1 and 2. I only want half of it. So really, you've probably seen this before. It is base times height. So we have something called an altitude. The altitude is just the height. It's when I draw in that right angle. The key is that must be a right angle right there. So what in the world does that look like for most triangles? Most triangles, it's going to be, we'll draw it right in the middle. We'll say here's the base. Draw your altitude straight down from up here and put the right angle in. And there is our height. So our base and our height. But with obtuse triangles, it can look a little crazy. And it's a lot like the parallelogram. If you're okay with the parallelogram, you can draw it any way you want. But if I want to draw it from here, it's straight down. And I kind of have to continue this to show that right angle. So here's the base that goes with that height. And you can change it. I can draw that same obtuse, and I can draw another one. I could have actually drawn the height in this way if I wanted to. So you can draw in any altitude you want. That would have been the height, but now this is my base, this long side over here. So you may see it any one of these ways, but we're just doing 1/2 base times height. Awesome. So I know you probably see this formula. Let's just make sure we're cool with it. In this case, which one's the base? Well, if that's my height, it's got the right angle. What's got to be the base? This has to be the base down here. So we're looking at 1/2. Base is 6, height is 4.7. It's just a plug and chug. I'm going to go straight to the calculator. I'm going to call 1/2 just 0.5. So I'm going to make it a decimal right off the bat, and I'm going to times it by 6, times it by 4.7. Boom. There it is. So that gives it to me 14.1, and I should label this 14.1, what? 14.1 yards squared. Fantastic. Moving on, just make sure we got it. Can we see which one is the base and height? Well, I know there's my height. Who's the base? This is the base then. So no problem. This is just going to be 1/2. Base is 7. Height is 5.4. I know I'm going fast. Feel free to pause me, slow me down. And let's make sure we have this. Again, I like to type in 1/2 as 0.5. So I'm going to go 1/2 times 7 times 5.4. And you get 18.9. So we get 18.9 meters squared. Boom. I love it. Love it. One more here. What do we got back here? Hiding back here. Excuse me. So now, it's one of these where I don't know the, what? What part don't I know? I don't know the height of this triangle. So they give me the area is 35. It's still going to be 1/2 base. The base in this case is 11.3. But I don't know the height. So can I solve it? Sure, let's simplify this a little bit. 35, what is half of 11.3? So you can do 11.3 divided by 2 if you want. Or if you just want to stick with it as always decimal, you can say 0.5 times 11.3. So either way you like to think about it, I'm going to stick with 0.5 to keep it consistent. I've got 5.67. So this is really, or 5.65 is the height. So what do I do to solve both sides? I want to get h by itself, so I'm going to divide both sides by 5.65. And that'll give me an h of, what is that? Let's close this out here. 35 divided by 5.65. Boom. 6.19. And I'm going to round to 2 decimal places here. So 6.19 looks great. And we're in meters here. Not meters squared. It's a distance, 6.19 meters. Fantastic. So there are triangles. So this should be a pretty nice section. So those were kind of all the normal ones. Then we're going to mix in some of the stuff from Chapter 7. Make sure to keep that fresh for us. So what if I don't give you all the information? Like I can see, okay, here's the base, here's the height, but I don't have any of the info. Well, this is a special right triangle. If you remember back to 30, 60, 90, we can go back to a similar triangle where the small side is 1, the big side is 2, and the medium side is radical 3. So if I want to find the height, what do? I say 10 is to 2. 10 is to 2 as h is to 1. And h over 1 is just 1, so this is really 5. So I can say, okay, no problem, h is 5. So if I want to do that, I can say h is 5. How about the other one? For part B, I can do the same thing I'm going to put up here. I can say 10 is to 2. The long side matches the long side as b matches radical 3. And we can do our little cross multiply. We can say 2b equals 10 radical 3. And what do we do by both sides? Got to divide by 2. So really, I can find b. Let me get rid of this. B is going to be what? 10 radical 3 divided by 2 is 5 radical 3. So a little bit of work there to fill that in. But now I can do my formula. We can say area is 1/2 base times height. The base happens to be 5 radical 3. The height happens to be 5. Can I multiply this all out? Sure. It's 1/2 times 5 radical 3 times 5. So the whole numbers I can multiply. So I can actually do 5 times 5 is 25. And I'm going to times it by halves. That's 25's halves. So this would be the exact possible answer. Okay, that's a lot. If you want, that's great. If you want to leave it in the simplest radical form, that is a fantastic answer. If you want to make this all decimals, you're more than welcome just to type it all in and say 0.5 times 5 radical 3. Where's my radical? There it is, radical 3. and we're going to times that by 5. And this is, if you want to put this answer, that's great, 21.65. So you can approximate it as 21.65. It's a pretty good approximation. Just make sure you label it. We're talking meters squared. So either one of these is cool, and we're good to go. Fantastic. Very nice. What else do we got? So we had special right triangles. What about Pythagorean theorem? So back to the parallelogram. So I've got the base. Can you tell the base? The base is all of this. This is the whole entire base. So the base is 20. I don't know the height, so I need to find the height. But if you look at just the top here, there is a little triangle here. It's this, this, and this. So I've got Pythagorean theorem where I'm going to say h squared plus 5 squared is 13 squared. And maybe you recognize this one. This is one of the special Pythagorean triples. If not, you can just solve it though. We've got h squared plus 25 is 169. And subtract 25 from both sides, you get 144. And then we're going to take the square root of both sides. So h is really 12. So if h is 12, now we've got the height. Now we can fill this in and say parallelogram is what? Area is base times height. So it's going to be 20 times 12. Fantastic. And what's 20 times 12? That's going to be 240 meters squared. So that's number 2. So maybe you have to use a little Pythagorean theorem in there. I love it. And the last thing that can happen is maybe we'll do a little trig function action. So it's not a special one like 30, 60, 90 or 45, 45, 90. It's just a trig. So what do I need? I need the base here. What trig function is going to relate these? Well, remember, this is what? This is opposite. This is adjacent. So I'm going to say opposite over adjacent. That's got to be tangent. The tangent of 61 equals what? Opposite over adjacent. And now let's solve this. So you're going to multiply both sides by b. Do not like b in the bottom there. So we're looking at b tan 61. And 61 is just some decimal, so don't freak out about that. These cancel. And I want to get b by itself, so I'm going to divide by this decimal, which is tan 61. Whatever you do to one side, you got to do to the other. So those cancel. So really b equals, now I got to go calculator. Double check your mode. Ooh, I was in the wrong mode. Got to be in degree mode for this to work. So we were looking at, what was that? 19 divided by tangent of 61. Hit enter, and I get 10.53. So again, 2 decimals, please. 10.53. And what is this? This is, oh, there's no units here. If that happens, you can put units squared. So I don't know what they are. I'm going to put units squared in there. I'm going to pretend like I meant for that to happen to show that example. And there it is right there. If you want to use trig for the special right triangles, you could have used trig right here. You'll still get this decimal. You could have done some kind of sine and cosine to find these sides here, and it would have worked out great. So if you do not like those, feel free to go straight to trig. Awesome. We've got one more. All right, let's bring the pain here. Wrap this bad boy up. Love it. All right, so a lot going on in this problem right here. You know, it looks like just our normal area equals base times height problem. So the area is given to us in this case is 16. The base is this whole thing up here, x plus 2. So make sure you put in parentheses is x plus 2. The height of this thing, again, has to be in parentheses is x minus 4. So wow, we got a little bit of work cut out for us to solve it, but I love it. This is great. So I'm going to distribute this. Double distribute. Some people call it FOIL, but we like to double distribute. So I'm going to go x times x is x squared. X times 4 is minus that 4x. Then distribute the 2. 2 times x is 2x. 2 times 4. So this is why we're doing that algebra review. Make sure this stays fresh so you got it. So this is no problem for you. Now what can I do? I can combine like terms here. So add your x's together. I've got minus 4x plus 2x is minus 2x. And now I'm ready to solve this. Well, how do you solve this? Well, it's a quadratic. I get this x squared here, so I want to set it equal to 0. So I'm going to subtract 16 from both sides. And now it says 0 equals x squared minus 2x. Negative 8 minus 16 more is minus 24. Fantastic. Now we are ready to factor it. So we're going to factor this bad boy. On bottom, negative 24. What multiplies negative 24 adds or subtracts to negative 2. I think we're looking at 4 and 6. And who's got to be the negative? It's got to be the 6 because 4 minus 6 is negative 2. 4 times negative 6 is negative 24. Fantastic. So when I factor this, I've got x plus 4. X minus 6, and this equals 0, so we factored it. So what are the actual solutions? What makes this 0? Well, if x is negative 4, and if x is 6. Now, when I go back to this problem, is negative 4 really going to make sense? Can I really put negative 4 in for x? No, because negative 4 plus 2 is negative 2. Can this distance be negative 2? No, that's impossible. So negative 4 is actually impossible. just to make sure, you may want to make a note of that. That doesn't work. But this 6 definitely does work. When you put it in, 6 minus 4 is 2, 6 plus 2 is 8, multiplies to 16, and you are good to go. Fantastic. We start with a little Alien Ant Farm. We're going to wrap it up with Alien Ant Farm because we got the whole alien theme rocking. Good luck on the mastery check. Peace out.